10 robotic animals. So realistic, you'll forget they're not alive. When nature inspires machines, nature has spent millions of years perfecting movement, strength, balance, and agility through evolution. Now, robotics engineers are taking notes. Across labs, tech expos, and even military installations, robotic animals are mimicking life with astonishing realism. Some are built for exploration, some for assistance, and others just to showcase how far we've come. This video uncovers 10 robotic animals so advanced, they blur the line between biology and technology. Each one modeled on real creatures, but powered by next-gen innovation. These machines don't just look like animals, they move, react, and even think like them. 1. Big Dog, the robotic mule of the battlefield. Developed by Boston Dynamics, Big Dog was designed to support military troops by carrying heavy gear across rough terrain. Weighing 109 kilograms and capable of hauling up to 150 kilograms, it walks, trots, and even recovers from slips using dynamic stabilization. Its 4 legs respond individually to changes in terrain, allowing it to traverse mud, snow, gravel, or slopes without losing balance. It doesn't resemble a dog much in appearance, but its loyalty is unquestionable. It uses onboard sensors, gyros, and cameras to follow humans and respond to commands autonomously. While it was never officially deployed in active duty due to its engine noise, it remains a groundbreaking prototype that's influenced many other legged robots in defense and logistics. 2. RoboFish, nature's underwater doppelganger. Meet the robotic fish so convincing, marine life can't tell it apart. Created by researchers at the University of Essex and later commercialized by several tech companies, these fish replicate not just the look, but the natural swimming patterns of their biological counterparts. Unlike propeller-driven bots, RoboFish use flexible bodies and mechanical tails to glide silently and smoothly. Some are used in aquariums for aesthetic display, but others serve scientific missions, monitoring water pollution levels or patrolling harbors. These robots can be programmed to swim in coordinated schools and even avoid obstacles. With added sensors and modular designs, the RoboFish isn't just a showpiece, it's an aquatic data collector with real-world impact. 3. SmartBird, the robotic albatross that flies like nature intended. Engineered by Festo, a German automation company, SmartBird is modeled after the herring gull, but flies more like an albatross, with broad wings that flap and twist in flight. What makes it astonishing is its ability to take off, fly, and land completely autonomously using a lightweight carbon fiber body and internal muscle-like mechanisms. Its wings not only flap, but adjust their angles mid-flight, simulating the complex aerodynamics of real birds. Controlled by a remote link and equipped with internal sensors, SmartBird balances itself in real time, responding to wind, pressure, and drag. It has even inspired designs in drones and future aircraft, proving how biomimicry isn't just visually impressive, it's also functionally revolutionary. 4. SnakeBot, the search and rescue specialist. Robotic snakes might be unnerving, but they could save your life. SnakeBots, developed by Carnegie Mellon University and others, are long modular robots with dozens of segments that mimic real snake movement, slithering, coiling, sidewinding, and climbing vertical pipes. These robots shine in search and rescue missions. In disaster zones like collapsed buildings or mines, they crawl through debris to locate trapped victims, transmitting data, audio, or video back to rescuers. Some models are waterproof, and others can even burrow into soil or navigate underwater pipelines. They're also being studied for surgical applications, where their flexibility can navigate the body less invasively. From military surveillance to medical use, SnakeBots are proof that design inspired by nature can go places no human or wheeled robot can. 5. Cheetah robot, sprinting past nature's limits. MIT's Cheetah robot doesn't just resemble the world's fastest land animal, it's engineered to outperform it. With lightweight metal limbs and a spine-like structure, the Cheetah robot can gallop at speeds up to 28.3 miles per hour and leap over obstacles with pinpoint accuracy. What sets it apart is its electrical motors. Unlike hydraulic systems in older bots, these are quieter, lighter, and more efficient. The robot also boasts artificial muscle-like actuators and vision-based control, allowing it to map terrain in real time and adapt its stride mid-run. This robot's applications go beyond athletics. It could someday serve in disaster response, military reconnaissance, or even autonomous delivery. It represents speed, balance, and robotic reflexes combined in a package that's both powerful and precise. 6. Octobot, the first soft, untethered robot. Harvard University's Octobot is a pioneering soft robot that mimics the flexibility of an octopus. Built from silicone and powered by chemical reactions instead of electronics, it contains no rigid components. That means it can squeeze, twist, and morph through spaces traditional robots can't access. Octobots are especially interesting because they rely on fluid-based logic systems where liquid gas controls movement rather than digital commands. This represents a major leap in autonomous soft robotics, making it ideal for underwater exploration and hazardous environments. While current versions are slow and simple, the goal is to develop future models that can grip fragile objects, perform underwater repairs, or even explore alien oceans beneath ice-covered moons like Europa. 7. Robo-Shark, stealth meets speed in water. The robot shark, developed by U.S. military contractors and marine researchers, looks and swims so realistically that even dolphins have been caught interacting with it. Built primarily for surveillance and marine studies, RoboShark uses silent propulsion systems that mimic the swishing of a shark's tail. Its skin is textured like that of a real shark, helping it reduce water drag and remain undetected. Some military versions include cameras, sonar, and environmental sensors, designed for monitoring underwater pipelines or patrolling coastal zones discreetly. Although not as fearsome as the real predator, the RoboShark is a stealthy aquatic scout, part science tool, part guardian of the sea. 8. T8X SpiderBot, a creepy crawly with 8 robotic legs made by Robotics. The T8X is a spider-like robot with 26 robotic motors that mimic the exact leg movement of a real spider. Its shell, created via 3D printing, gives it a lifelike appearance that's both fascinating and unnerving. It can dance, crawl, respond to motion, and navigate terrain with surprising agility. Programmers can control it through Wi-Fi, customizing movements, or syncing it to visual effects for entertainment or research purposes. What makes T8X more than just a toy is its role in studying locomotion and AI behavior. It's used to test algorithms for leg coordination, valuable in developing walking robots for terrain where wheels fail. It's proof that even the creepiest creatures can teach us something extraordinary. 9. Robotic jellyfish, gliding elegance with a purpose. At first glance, this robotic jellyfish is hypnotic. Its soft, fluid pulsing in the water looks so real it's hard to tell it's a machine. Designed by researchers from Virginia Tech and other institutions, this bio-inspired robot is created for underwater surveillance, environmental monitoring, and even marine data collection. With a flexible silicone body and soft actuators, it doesn't disturb marine life or ecosystems. Its graceful propulsion uses hydraulic or electric pulses to push water, making it extremely energy efficient and nearly silent. In the future, fleets of robotic jellyfish could monitor coral reef health, locate underwater pollution, or operate as stealthy scouts for scientific missions in hard-to-reach ocean layers. 10. Bionic Kangaroo, jumping with recycled energy. German automation giant Festo created the Bionic Kangaroo, which doesn't just mimic a kangaroo's hop, it mimics its energy recycling system. Real kangaroos use tendons to store and release energy between jumps. Festo replicated this behavior with a combination of compressed air and robotic joints. Each jump stores energy that's reused in the next, making the kangaroo robot extremely energy efficient. Though currently a demonstration model, the technology behind it has real implications for exoskeletons, prosthetics, and energy-saving mechanisms in industrial robotics. With future upgrades, it could evolve into a high-mobility transport system in rugged environments, or just remain a showcase of how beautifully machines can imitate nature's best engineers. Where life ends, innovation begins, from mechanical sharks that glide like real predators to spider bots that move with creepy precision. These robotic animals are more than just scientific curiosities. They're a glimpse into the future of mobility, intelligence, and adaptation. They demonstrate how far engineering has come and how closely we're following nature's playbook. As AI becomes more integrated with robotics, the line between biology and machine will blur even further. Soon, robotic animals may assist in surgery, clean oceans, or explore other planets. The age of living machines isn't coming, it's already here. If this list of realistic robotic animals fascinated you, make sure to like, comment, and subscribe for more content that explores the edge of science, technology, and the wonders of what's possible when evolution meets invention.